Welcome back to my channel Success Engineering Official. Guys, today we are going to see the duct design with a static regain method. Okay, so as you can see here, this is the simple ducting layout with this is the edge with 8000 cfm, and there are 4 branch. All the cfm is going to be divided in each branch, so 2000 cfm is distributed in each branch. So the air is flowing through this way from A to B, B to C, C to D, and D to E. This is the node A, B, C, D, E. Okay, so your 8000 cfm is flowing through this machine and discharge 2000 cfm to this diffuser. Okay, and then 6000 is moving again and again discharge 2000 cfm to this side. Again remaining 4000 cfm is moving through this main duct and pass through this branch 2000 cfm, and 2000 remaining cfm is going to this diffuser. And this 50 feet, 40 feet, 30 feet, 35 feet is nothing but the length of the main duct. Okay, so how to design this duct with a static regain method? We have one simple Excel sheet. You can see here, this is duct design using a static regain method. So first of all, you need the application. This method is mostly used for the industrial application. So you can see this application is industrial. Okay, industry. And height of the duct we assume 16 inch taken as per the clearance above false ceiling. If there is false ceiling, the height you can assume as per the clearance. Okay, and velocity for a static regain method and industrial purpose, we are using 2500 fpm feet per minute to 4000 feet per minute. Approximate we consider 3000 fpm. fpm is nothing but feet per minute. Okay, so for duct, for section duct, for section A to B, for example here, this is the section. Okay, A to B. So A to B, the flow Q is nothing but the flow, air flow, and V is nothing but the velocity. So flow is 8000. You can see this is the 8000 cfm is flowing through this machine. Okay, and velocity we consider between these 2500 to 4000. So we consider velocity 3000 feet per minute. Okay, so how you will get the duct size? Using duct sizer. So let me open this duct sizer. Okay, so this is the duct sizer tools from Mcquay Duct sizer program. Okay, so you can see here, this is simple flow rate. You have to enter the flow rate here. So flow rate is nothing but the CFM 8000, and simply click here these two first. Okay, flow rate and velocity. Okay, simple enter the flow rate here, and velocity is given here 3000 feet per minute. Okay, so and simple enter here, this is the height. You can assume anyone, so I am assuming the first one is height and this automatic width. Okay, so simple enter the height of the duct 16 inch, so you are getting 26 inch width. Okay, so this is the duct size 26 inch width and into 16 inch height. Okay, using duct sizer. And friction loss F is also for from the duct sizer. You can see here head loss 0.51. Okay, inches of water gauge per 100 feet of duct length. Okay, so similarly I have write it here. And round duct dia is nothing but, you can see here from the Mcquay Duct sizer program, equivalent diameter of the round duct. Okay, 22.1 inch. Okay, so approximate 22. So this is the first section. Okay, from this static regain method will start from the second section. Okay, first section is velocity method. Okay, so for the section B to C, you can see here, this is the section B to C. From B and to C, how much is the CFM? So 6000 CFM. Okay, so flow is Q is equal to 6000 CFM, and velocity is 2600 feet per minute. We assume should be less than previous. Okay, so previous velocity was 3000, so I am assuming now 2600 feet per minute. So using this two value, you have to enter here in the duct sizer program 6000 and velocity is 2600. then you will check the duct size. So you can see here the 16 inch is by 22 inch, so duct size is 16 by 22. Okay, and friction loss is nothing but 0.422 inches of water gauge per 100 feet of duct length. Okay, and round duct dia is nothing but 20 inch. Okay, now calculate the static pressure. So static pressure, the formula for a static pressure is SP is equal to R into V1 by 4000 का whole square minus V2 by 4000 का whole square. R is nothing but the recovery factor taken 0.7 to 0.9. Okay, if there is more bend you have to take 0.7, more fittings used, so you will use 0.7. If there is less fitting, for example most of the duct is straight, you can use 0.9. Okay, so a static regain method, a static pressure, now you have to put this value 0.9 3000. So V1 is nothing but the velocity of previous duct. That means the static regain will start from B to C. So what will be the velocity for the previous duct? What was the velocity? So duct A to B velocity was 3000 feet per minute. Okay, so here 3000 feet per minute, and B to C the velocity is 2600 feet per minute. Using put this two value here in this formula, then after putting this you will get this 0.126 inches of water gauge. Okay, 0.126 inches of water gauge. So total friction loss for the duct section B to C for 40 feet of duct length is, for 40 feet, this is for 100 feet, this is the friction loss. Okay, for 100 feet 0.423, for 40 feet, because B to C the duct length is 40 feet. Okay, so for 40 feet 0.423 into 40 divided by 100. Okay, so you will get 0.169 inches of water gauge. Okay, so what you will get from the conclusion, static pressure is less than the total friction loss, but to regain it should be, to get the regain it should be greater than the friction loss. So we need to assume another velocity and check a static pressure again. Okay, so in this you will get, you can see here friction for the 40 feet 0.169 is greater than the static pressure. That means this is not acceptable. In a static regain method, your static pressure should be greater than the friction loss. Okay, always. Then in this case, now we have to assume again another velocity and check. This is the trial and error method. Okay, so just assume the velocity, check and put this in this formulas and check the static pressure and friction loss. Compare with friction loss. Then a static, once you get the static pressure more than the friction loss, that duct size is accepted. So now we are assuming 2400 feet per minute velocity, and as Q is equal to 6000. Okay, so friction loss, I put this value. Now simply change this to the velocity 2400 feet per minute. So you can see here 16 feet by 16 inch by 24 inch duct size, and friction loss is 3.344. Okay, so here your friction loss is 0.345 inches of water gauge per 100 feet of duct length. So for 40 feet again you have to multiply into 40 divided by 100. So we are getting 0.138 inches of water gauge. Again put this value. Okay, now in this formula. Okay, so 0.9 by 3000 by 4000 ka whole square minus 2400. I am changing only in this velocity V2. Okay, so I am getting 0.182. That means now we have to compare this static pressure and this friction loss. So friction loss is 0.138 and this is 0.182. So that means this static pressure is now greater than, simply enter this, greater than friction loss. Okay, like this. That means this is accepted. Conclusion, now static pressure is greater than the total friction loss. So accepted. Now check the duct size with using duct sizer. So 16 inch by 24 inch. Okay, now round ducts and round duct dia is 21.4 inch. Okay, so this duct size is accepted. Similarly, you have to calculate for the another section. So now we using this table, you can see here It's very simple here. Okay, I have prepared this table. Okay, so you can see at the section A to B the flow is 8000. Okay, and velocity is 3000. So we get here a 0.15 friction loss. Okay, and duct length is 50 feet. You can see here, this is the duct length is 50 feet. Okay, and friction loss is 0.255 for 50 feet of duct length. For 100 feet 0.5, so for 50 feet 0.255. Okay, and static pressure is not applicable. Equivalent duct diameter is from the duct sizer you will get, and duct size from the duct sizer and selected. Now B to C, static pressure. This static Reagan method is start from B to C. So 6000 CFM flow and 2600 we assume first. So we are getting the friction loss for 100 feet 0.423 and duct length is 40. That means your friction for the 40 feet of duct is 0.169, and a static pressure from this formula. Okay, from this formula is static pressure. You will get here 0.169. Sorry, static pressure 0.126. Okay, I simply enter here, so 0.126. That means you will see here this the friction loss is higher than the static pressure. That means, and equivalent duct diameter is 20 inch and duct size is this one, 22 by 16 inch. That means it is not selected because the static pressure is less than the friction loss. That means there is no regain. Your air will not move. Your static pressure is always greater than the static friction loss. Okay, so now in the again we are assuming the another velocity from B to C 2400, and we are getting this friction is less and static pressure is more. That means this duct is accepted. Now for C to D you have to calculate again. So 4200 and 2200 this time we assume. Okay, so put these two value in the duct sizer here. Simple. For C to D section we are calculating for C to D. Okay, so for C to D simple flow is 4000. Okay, and velocity we are assuming 2200. So we are getting 16 inch by 18 inch duct size. So simply enter here 18 inch by 18 inch by 16 inch. Okay, and round duct dia is 18 inch. So round duct dia is 18 inch, and duct length from this 30 feet. So simply enter here 30 feet. Okay, and the friction loss per 100 feet of duct length is here from the duct sizer 0.35. So here is 0.35. Okay, so for the friction loss for 30 feet, this is for the 100 feet. So for 30 feet how much it will be? So how to calculate? Simply 0.355 into 30. Okay, divided by 100. So 0.106. Here will be 0.106. So a static pressure, now using this formula, this one, simply calculate this static pressure. So how to calculate? V1. So what will be the V1 here? Okay, so V1 by 4000 whole square minus V2 by 4000 whole square. So you are here in the duct section C to D. So what will be your V1 for the velocity for the V to C is the V1. So what was the velocity for V to C? You can see here 2400. Okay, so 2400 divided by 4000. Okay, so 0.46 whole square, that means you have to multiply 0.6. So 0.36. Okay, so remember this value. And again V2 is nothing but 2200. 2200 divided by 4000. Okay, equal to 0.5 into 0.55. Okay, so 0.36 minus 0.30. Okay, so clear this. 0.36 minus 0.30. So this is your value 0.06 and multiply into 0.9 is nothing but the 0.54. Okay, B1 by 4000. So what will be your, what was your B1? Here is B2C. Okay, so B2C B1 2400 divided by 4000, 0.6. Okay, 0.6 का whole square. Okay, so 0.36. Okay, simple this one whole square, so 0.36. Clear this value and remember. Okay, and then this one 2200 divided by 4000, okay, is equal to 0.55 and is whole square is 0.3. Okay, so 0.302. 0.36 minus 0.302, 0.05 into 0.9. Okay, so 0.05, 0.052. So a static pressure will be 0.052. So simply enter here 0.052 inches of water gauge. Okay, so here is your 0.16, 0.16, and static pressure is how much? 0.05. That means this is the higher and this is the lower. That means you need to assume the another velocity is not accepted. This text size is not accepted. Okay, so again check this C to D, same section. This is trial error method. You need to check this. It's time consuming method also. 4000. Now we have to check with 2000 CFM. Okay, so with 2000 CFM, simply enter here 2000 CFM. In this case, we are getting 16 inch by 20 inch duct size and round duct is 19 inch. So here is your 19 inch. Okay, and duct size is 16 by 20. Here is your 20 inch by 16 inch. 19 is we always considering the equal or even value. So and friction loss is 0.277, 0.277. Okay, and duct length is 30 feet. Okay, so now we have to verify this friction loss for 100 feet. So for 100 feet, what will be your friction loss? So 0.277 into 30 equal to divided by 100, 0.083. So here will be your 0.083. Okay, now we have to check the static pressure, static regain method. So V1 is, what will be your V1? V1 will be 2400. Okay, divided by 4000. Okay, whole square 0.36. Okay, so simple clear this, and now we assume here 2000. So 2000 divided by 4000. Okay, whole square 0.25. Simple clear. So 0.36 minus 0.25. So 0.11 into 0.9 is the recurring value. So 0.099. Okay, R is nothing but, you can see here, where is R? Recovery factor. Okay, recovery factor. So now we are getting here 0.099. So 0.099. So now we have to check which one is the greater. So 0.08 is greater or 0.09 is greater. That means this value is greater. Okay, so 0.09. That means this duct size is accepted. Selected. Always a static pressure should be greater than the friction loss. These two values you need to consider here. Okay. So this duct size is accepted. Okay. Now next section is C to D. Okay. So D to E. So D to E here. D to E. What will be your flow? CFM is 2000 and now we are assuming 1800. Just assume velocity and check. And duct length is 35 feet. Okay, so 35 feet. And put these two value here 2000. Okay, and velocity is 1800 feet. So we are getting 16 inch by 11 inch. So now we need to reduce the height of the duct because this width is less. That means we need to reduce it. So 14. Okay, so 14 by 12. Again we need to reduce. So 12, 14 by 12. Okay, so here your duct size will be 14 inch width and height is 12 inch. Okay, and your round duct dia is 14 inch again. Okay, and friction factor you can see here, head loss is 0.32 inches of water gauge, 0.324 inches of water gauge per 100 feet of duct length. That means this is for the 100 feet. So for 35 feet, how to calculate? Clear this. 0.324 into 35 divided by 100. 0.113. Here will be your 0.113. Now check this static pressure. So static pressure you have to simple check. V1 by V2, V1 by 4000 का whole square minus V2 by 4000 का whole square into 0.9 R. So here will be your V1 was now 2000. Okay, so 2000 divided by 4000 का whole square, so 0.25. Okay, now 1800 divided by 4000 whole square 0.20. Okay, so 0.25 minus 0.20 into 0.9 R value. So 0.045, 0.045. That means this is the static pressure is less than the friction loss. Again, this duct is not accepted. Okay. Okay, so here a static pressure is less than the friction loss. We need to assume again another velocity here, d to e again, and flow is 2000. Now we have to assume 1600 feet. Okay, so using these two value, using duct sizer, simply enter here 2000 and change the velocity now 1600. Okay, so we are getting 12 inch by 16 inch. So here your duct size will be 16 inch by 12 inch. Okay, and round duct dia is 15 inch. So here your round duct dia is 15 inch. Okay, and the friction loss for 0.241 inches of water gauge per 100 feet. So here 0.241 inches of water gauge per 100 feet. Okay, and duct length is 35 feet. So for 35 feet, how much it will be? So simple, you have to multiply 0.241 into 35 divided by 100. Okay, so 0.084. Here will be 0.084. And now we have to check the static pressure. So how to check this? Simple, you have to take the V1. So V1 was 2000. So 2000 divided by 4000. Okay, whole square, so 0.25. So simple, clear this, and now the V2 is 1600. So 1600 divided by 4000, okay, is equal to whole square, so 0.16, so 0.25 minus 0.16, okay, into 0.9, so 0.081, so 0.081, okay. So again this is a static pressure is a minor less than the friction loss 0.084, so 0.081, so this is again not accepted, okay. Again we need to check. This is trial and error method, okay, so you have to assume and check. That means that's why this time taking method but accurate method, okay. Again we need to assume another 1400, okay, or 1500 because it's minor, so 1500, okay. With this velocity, simple change the velocity here 1500, and you are getting here 12 by 16 again, okay, 16 by 12, always take even number, okay, and round duct dia is 15 inch again, okay, and friction loss for 100 feet of duct length is 0.204, okay, and duct length is 35 feet. So for 35 feet, how much it will be? 0.204 into 35 divided by 100. Okay, so 0.0714 here, 0.0714. Okay, now we have to check the static pressure. So static pressure first V1 by to 4000 ka whole square. So V1 by 4000 ka whole square is nothing but 0.25. If you check this, V1 is now 2000, okay. So simple check V2, and 1500 divided by 4000 V2, okay, whole square, so 0.140, so 0.25 minus 0.140, 0.11, okay, so here is 0.110. Now we have to see here, this is the static pressure is now higher than the, okay, so simple copy this one, put it here, okay, this is higher than the this one, okay. Now again copy this, place it here. This is your friction loss is less than, and static pressure is higher, so this duct is selected, okay. So I think you guys learn how to do the sizing for duct sizing with using a static regain method. So this is how we are going to check again and again, okay. So this is called trial and error method also. So I hope you guys learn how to do the sizing for duct sizing for using a static regain method, okay. So I would like to request you guys, please do subscribe my channel and hit the bell icon as well, because I am making the video with very hard work, okay. So please subscribe my channel, because for you I am making these videos with a complete concept. So please subscribe my channel and please share my video with your friends, okay, so that they can get the benefit of my videos, because you know how to make this video is very time taking to make the videos, okay, and always taking time for editing also. That means is very hard and tough work to make the videos, edit and upload. So please guys, I make this video for you only, so please subscribe and hit the bell icon so that you can get the notification of my upcoming videos, and you will learn the complete concept for MEPs with my channel. So don't forget to, I would like to request once again guys, don't forget to subscribe and hit the bell icon so that you can get the notification of my upcoming videos. So please take care and please keep watching my channel and my videos, and thank you for watching again once again, guys. So thank you for watching, and thank you. Bye bye. So don't forget to subscribe and hit the bell icon. So please be yourself safe, and please keep yourself safe, and watch my videos, and please share and share with your friends. So thank you guys once again. Thank you. Bye bye.